In this discussion, we are going to learn about what is electric field intensity. So here we can see a test charge. There is a fixed charge. So this is a test charge, and this is a fixed charge. It is Q, and this is Q. So when I bring this test charge to somewhere around this Q, the test charge will experience some force. And with this video I am going to give you what is the relationship of the electric field and force experienced by the test charge when it brings close to the Q. This is a positive fixed charge. This is not moving. Its coordinate is fixed. Since it is a charge, there is an electric field. So all the electric field from the plus test charge is towards any another negative the charge. If I bring this negative test charge to here, the somewhere around this positive fixed charge, this negative the test charge will experience some force. Let us keep it here. So what is that force experienced by this test charge? So before that, the definition of electric field is, or electric field intensity, usually we notate with the symbol E, is defined as electric force per unit charge. So it is given by, it is a force per unit charge. So we know that according to the Coulomb's law, the force inserted by the two charges each other is directly proportional to the charge and inversely proportional to the square of the distance between them. So F become Q times the Q, which is upon 4 pi epsilon r square. So when I make the E, the expression become F by Q. So Q times Q by 4 pi epsilon r square times Q. The Q get cancelled. The final expression of E become Q by the 4 pi epsilon r square. The SI unit of E is volt per meter. So this is the electric field intensity, the electric field experienced by this test charge Q when it is bring somewhere around the fixed charge Q. So we can use this expression to find the electric field anywhere around a fixed charge. Let us now look into the electric field due to charge distributions. We have discussed about the electric field due to a fixed test charge, a point charge. Now we are looking on to, so what is the electric field produced by when there are n number of charges, they were concentrated in a volume, or they were uniformly distributed in a line, or they are uniformly distributed over a surface. So earlier we discussed about the charge densities, such as the line charge densities. The charges are distributed in a line, the uniform distribution of the charge. Then we have discussed about surface charge density. So charges are distributed over a surface. Then we discussed about the volume charge densities. So this is the volume, so where charges are uniformly distributed. So if you consider any of these, all the three different charge distribution will produce some field intensity at any point around its space. Let us now what we can do to bring a mathematical relationship of the charges distributed over a surface and the electric field intensity. So for that, let us consider a line charge distribution. This is a line where the charges are distributed uniformly, and I'm considering one point, a P, and which is equally distance from the every point in this line. Now I am dividing each distribution equally. So line is equally divided, so there are n number of elements are there. So let us consider that the width of the each segment is very small. That means the number of element is approaching to infinity. So that means there are infinity number of segments are there. The width of each segment is, let us consider dl. dl is the width of each segment. So let us take one segment, small segment. It's dl. Its width is dl. The charge is delta q. So this is here delta q. It is if it is a first segment, delta q1, delta q2. So there are many segments, delta qn. So that means we have number of segments that changes from 1 to n. So we can correlate all this delta q and number of segments and the width of each segment using this expression. So let us take, so we know that expression of electric field intensity of a fixed charge is q by 4 pi epsilon r square. If it is on a free space, then epsilon r become 1. It is epsilon naught. Let us take a small segment. Its width is dl. It is, and the charge is delta q. Let us take it as I. It's the ith element, and the E become, so we need to take the sigma. So all the charges, total charges, that is delta qi. So where I changes from 1 to n, and n is approaching to the infinity. So we have to apply the limit where n approaching to infinity, and which is delta qi, which is upon 4 pi epsilon naught and r square. So this is where the r is the position vector of the point P. And I can use the line charge distribution function to express the electric field intensity. So we know that the line charge distribution, the line charge density delta L equal to the charge per length. The charge is delta qi per the length is dl. So delta qi become line charge density into dl. Now let us substitute delta qi with here. So E become, now I am changing this limit and sigma function with integration. Here the length of the line is from 0 to L, that is the length of the line. So I am integrating, so integrating, that is a line charge integration. So this become 1 by 4 pi epsilon naught, which is a constant, and delta qi can replace with the rho L, that is a line charge density, into dl by r square. So this become 1 by 4 pi epsilon naught So this is the electric field at point P due to the line charge distribution. Similarly, for a surface charge, that indicating that the charges are uniformly distributed over a surface, let us take a point P. What is the electric field at P due to the surface charge distribution? So surface charge density is, that is delta S is, so delta Qi by a small surface, that is ds. So delta Qi become rho s into ds. So if you use this expression and replace delta Qi with rho s and ds, the E become 1 by 4 pi epsilon, and integrating the surface, the total surface, and rho s ds and r square. Similarly, for a volume charge density, that means if you take a volume, charges are uniformly distributed. If you take one point P, what is the field intensity at this point P due to this volume charge density? So the same expression, so E become 1 by 4 pi epsilon naught. The only changes here, instead of surface charge integration, there's the volume charge integration. So rho V into a small volume, that is delta V by R square. So these are the mathematical representation of electric field intensity due to line charge distribution and surface charge distribution and volume charge distribution. So we obtained the expression of E in the form of limit of sum, and later that is replaced with an integral form using the line charge, surface charge and volume charge density functions. Thank you.